Welcome to Tactic Academy, where I'll be looking at the tutorial sheet. So this tutorial sheet covers BS, BF, HRM, BEC, BSP 140, alright, or just BS 140. So the tutorial sheet, this is first tutorial sheet, of which it is the best way to learn things. You follow the tutorial sheet because the tutorial sheet will cover everything. So since everyone has joined the meeting, we can now start. So for online lessons, tell your friends as well that they should be be part of the online sessions. So I'm recording the video. Let's get started. Alright, so this is question number 1. So the tutorial sheet was 2024, by the way. So this is number 1. So let A be a so let A have the set, the member of a set 0, 2, 4, 6, 8. B has those elements, C has those elements as well. So we want which of the following statements are true. Alright, so which of the following statements are true? So the key is there. Alright, so we are saying now for number 1. So we'll solve this tutorial sheet fast as possible as we can, because it has a lot of questions and we'll try to solve them fast. The other things you learn them during the lesson. Okay, so the thing is, we have, it is saying 4, 6, all right, as members, then is a subset or equal to A, meaning that they are asking us to say, are the element 4, 6 found in A, or are they part of A? That's the meaning. Do we have 4 and 6 in A? Do we have 4 and 6? So by this one, saying this one, the word which is down here, this one means equal. All right, is it a subset or just equal? Are they equal? Are they tantamount? Are they the same? All right, so 4 and 6 can be, yes, they are found in A, but they are not only the members that should be equal to, that should follow this rule to say equal to. So this one, if I say 2 is a subset or equal to 2, so this should be followed. Now that we have 4, 6 and they are just subsets, all right, so we'll say this is false. All right, because there are other members apart from 4 and 6 that are found in A. So the best answer would have, for us to say true, would have written 2, 4, 6, 8, 10, like that. All right, those are the one which can obey this statement. All right, you would have said this is true. All right, so now that it's not, they are just members, they are just part, they won't do anything. All right, so that one is false. Okay, so the other one is we are saying we are solving B. So it's saying B is a subset or equal to A. I mean, C is a subset or equal to A intersection B. All right, so let's list the members for C first. All right, so the members for C, we have 4, 7. All right, are they equal to or just found in the set A intersection B? So what are the things intersecting A and B? So let's go to A. Things that are found in A and B, that's the meaning of this. So things that are not that are found in A and B, that are common, so we'll go in A and B. So we can see there's Z4. I can see 4 there. There's also 4 there. What else? There's also 6 there. There's also 6 there. All right, so we are saying all right, so we are saying we are listing now A intersection B. All right, so A intersection B. Okay, so A intersection B now will be we have seen that 4 and 6, they are found in A, so we'll write 4 and 6 like that. All right, is this true? No, they are not the same. So if there was 7, it was going to be true. For this case is false. All right, so it's not true. Are you getting me there? So the C one, or number C, will say they're asking us to say, by the way, you need to know that if I give you x minus y, this is same as x intersection y complement, like that. All right, so that's the meaning there. So it means that you subtract, if possible, members of y from x. That's the meaning there. So what you are going to do here is I'll bring the same thing. It is b minus c, all right, intersection a, again subset or equal to member 6. All right, okay, so now here I'll say b, all right, intersection c complement, or let's just subtract. All right, let's just subtract. That's the meaning there. Okay, so we can just subtract. We can just subtract those members. All right, let's just subtract those members. Okay, so once we subtract those members, we are going to have, for b minus c, that's the meaning. So we'll list those members that are found in b minus. So we are removing everything from b that are found in c. That's the meaning there. So remove 4 and 7 in b. Now we only have 4 and 7, they are there, so we'll remain with it. So we'll remove 4 and 7 because they are the one subtracting from b. All right, so I'll say that is now removing 4 will remain with 3, 5 and 7, because 6 has been removed. All right, now we are intersecting with just a. Now the statement is, will this be equal to 6c, or will it give us 6? So that's the case there. So we'll say 3 there, 5, 7, intersection. We want to intersect with a. Everything in a. Are there things that are found in a? So I'll list the a. So a has 2, 4 like that, 6, 8 like that, and 10. All right, so since these are the elements for c, what I'll do is, for a, so I'll intersect, are they equal to what we have here? All right, so it should give us the same 6 for it to qualify true. All right, so we are going to say, what are the things intersecting here? All right, there's what, there's we have what are the things intersecting there? I can only see there's nothing intersecting. Do we have 3 there? No. Do we have 5 in a? No. Do we have 7? No. So this is an empty set. All right, or just you don't list it, you just list like that, an empty. Then is an empty equal to, or say, a subset of 6? No, the answer is now we are saying false. All right, so this statement is false. Okay, so that is it about that one. So we'll be very fast. So that is for C. What about just for D? All right, so for D we are saying now, for D we are saying for D it is a minus b, intersection C should be the subset of b. All right, so we are going to verify. So we are subtracting a minus b and intersect with b. So a minus b, subtract everything in b from a. So we are removing 7 and what, and we are removing 7 and 4. All right, so we are saying now this thing, we are getting everything that are in okay, we can write like this if you are getting confused. So we can say a, all right, intersection b complement. All right, so we are intersecting a with b complement. All right, so everything that is not found in b. All right, so we are saying we are listing now everything in a. So in a we have 2, 4, 6, 8, 10 like that. All right, so now intersecting with what is not found in b complement. So B complement from the universal, we can just say B complement will be everything apart from its member. So B has the member 4, 3, so we can say B has the member 3, 4, 5, 6, 7. All right, so these are the members for B. So those members that are not, in short, let's just use the one for subtraction. So I can say B complement now will be everything apart from these. So we are listing everything that we can see there. So we have 0, 2, all right, we have exclude 4, exclude 3, exclude 5, exclude 6, exclude the 7, just put 8 like that. All right, so that's the thing there. So you say things now that are intersecting, you have 0. Okay, we have things that are intersecting, we have 0. All right, okay, so we have 0, just wait a bit, let me do this, let me solve like this. Okay, okay, so now we are saying subtracting A minus B, this point we are saying A minus B, so that will be once you subtract A minus B, it means that you remove everything there. These members should not be found in the list that you are intersecting. So unite with B, I mean with A, then get those that are not found in B. So we are saying now we are removing 3 from there. Do we have 3 there? No, right? Do we have, so we'll put 0 there because it's not being subtracted. Do we have 3 there? All these numbers I'm mentioning should not be found in A. All right, so 2 there we don't have. We have what about 4? 4 is there, right? So I'll not put 4, instead I'll put the next number. Do we have 6? Yes, 6 we have in B, so it's subtracting. What else? Do we have 7? 7 is subtracting, so it is not getting anything from A. So we are putting now, what about 10? 10, is it there in B? No, it's not there. So we'll put, and also 8 is not there, so we'll put 10 there. All right, so that's the meaning there. We have done this one. All right, so now intersecting with this set C. All right, so putting set C has the member 4 and 7, right? Okay, so will it be a subset of B, all right, or equal to B? All the member that we are going to find, are they going to be B? So we are looking for things that are intersecting. Now, do we have anything intersecting there? No, so the answer is the empty set. All right, so empty set, now will it be equal to B? Is this true? No, guys, this is not. Yes, in Natasha, yes, it's not true. All right, so we put the member for B so that we see. So we'll put the members for B. So have 3, 4, 5, 6, and 7. All right, so these are the members for B. Is this true, guys? No, the answer is empty set can't be equal to or a subset of. So this is false. All right, so forget about this complicating stuff. That is false. Okay, so that's about D. I mean, so we say false. All right, so what about now E? Okay, E is saying, is C a subset or equal to B? So we want to see that is the C members equal to B members. That's the meaning there. It's more like equal sign. Okay, so what we are going to do, we list everything in C. So C we have 4 and 7. All right, so is equal to, is it a subset or just equal to B? So let's list for B. Are they the same? That's the meaning there. B has 3, 4, 5, 6, 7, like that. All right, are these the same? No, the answer is no. So you say this is false again. All right, so that is false. You can't have those things common like that. Okay, so we are saying this is false. Okay, that is it. So we have E. So now let's go to F. Okay, F is giving the condition to say is an empty set a member of A. Is that true? Is that true? An empty set, is it a member of A? This was going to be true if we had A being listed as A is equal to this. Now A has members, so an empty set can be equal to A because A has members. All right, so meaning that this is false. All right, it's not true. A has members, but an empty set doesn't have any members. All right, or just a member. So that's the thing, so that's false. Okay, F G. So now for G we have the condition to say A union B, open like that, then complement like that. So this is a subtraction, by the way. When you see this is a subtraction. Okay, so is it true for this question to say they will give you the member 2, 3, okay, then 6, 8? Are they going to give these members? Let's see if they'll produce these members. So we are saying A union B. Let's list A union. By the way, what you should do instead, don't repeat the numbers that are same. When your union is addition, you bring everything. So I'll get from A, the lowest is 0, 2, 3 from B. All right, then I have 4 is found in both, 5 is only in B, okay, then 6 is only found in both. So I'm listing everything. I don't repeat 6, those that are common. So I'll also have 7 from B, 8 from A, then 10 from A again. All right, so now I've added those A plus B, then I'm subtracting now C. All right, so subtracting C, that will give us, you get everything that are not found in what, that are not, you remove everything found in C. That's the meaning subtracting. So we are removing 4. C has the member 4 and 7, so I won't put 4 and 7 there. All right, so 4, I'm removing 4 like I said. Okay, so you don't put 4 because it's found in C. Then and also 7 you don't put, so I'll just put 10 and 8 like that. Now is this equal to this condition, these sets? All right, so we have 2 there, 3, 6, 8. All right, so guys, is this true that these members that are this side are equal to these members which are there? The answer is false. All right, yes, definitely is false. So that is it. All right, okay, so now having H, so H is giving us to say A intersection B intersection C should give us the member 4. Is this true? All right, so we test everything found in are there members or just the elements? Are there elements or just element that can be found in what, in A, B and C, that can be found in both, in among sets, all these 3 sets. So what we are going to do is A intersection B, we have what, the only thing I can see there, A intersection B is the 4, 6. In short, what is found in both sets, I can see 4 there, I also see 4 there, and also see 4 there. So meaning that 4 is qualifying. 7 is not found in A but can be found in B, so that disqualifies. All right, so this will be 4 in this thing. Oh, is it equal to the member that have been given? Yes, this is correct, so this is true. All right, so we are saying this is true. So that is it for question number 1, guys. Let's go to question 2. All right, so find the number of elements in each of sets. So what you should know is to find the number of elements, you say you have this formula to say number of subset is equal to 2 to the power n. So where n is number of element. All right, so if we were to verify to say number of subsets is equal to what, 2 to the power n, don't forget this, it will be used in these lessons that we might carve. So that is it. So number of element for A, number of element we have, we will just count number of element. Is that hard? So you count 1 2 3 4 5 6 7. So there are 7 elements. All right. So 7 elements. All right. So then for B, how many are they? 1 2 3 4. So no, for B there are 4, right? So you say 4 elements because they are 1 2 3 4. That's 11, right? So we are saying 4 elements. Okay. Then for C we have how many elements? 0 element. So it's an empty set, so say 0 element. All right. Okay, for D we are saying how many elements are there? So we have 1 2 3 there, right? So these are 3 elements. Okay, so that's 3 elements. Okay, so you are done with these. Let's go to question 4. That's how you can find it. You just count the number of elements I've given you for subset. Don't forget to use this one in the questions to come. Okay, so for question 3a, so we are saying find A intersection B given these sets universal 1 2 3 until 12. Then set A has this element, set B has this element, set C has this. Find the following. All right, so we need to be fast here. So the A intersection B will go where the A and B intersect. All right, so we are saying there is an universal A and B. What are things found in A and B? So I can see 2 is not found in B, 4 is not found in 4 is not found in B, 6 is not found in 4 is found in B, so we'll put 4. All right, it's found in both sides. So then what else? 6, do we have 6? Do we have 6 there? Yes, we have 6. All right. Do we have 8? No, we don't have 8. So these are the one which are only found. So that's A intersection B. All right, so when you see A, so when you see A minus B like that, okay, that means that when you see that comma thing there, it's more like A minus B or just A intersection B complement, which is just the same. All right, so this is also same as B like that. Okay, so don't get confused. So when you see this, let's now subtract. Let's use the one for where it is showing as if we are subtracting. So we are putting everything in. So in short, we don't want B elements. Okay, in what we list, we don't want B element, but we will list from the with the difference from A. So we'll put everything in A, but we don't want to see anything found in B. That's the meaning here. So what we are going to do is we'll put everything in A. So in A that are not found, and deal with elements that are not found in B. Things that are found in B, I can see 3. So we'll put from A we have 2 there. Alright, then from, since we have 2 there, what we are going to do is we're going to say we're going to say let's put those elements. Okay, all right, so we are putting those elements now. So if we put those elements, so if we put 2 is not found in B, I mean in B, so we are putting 2 there. What about 4? 4 is there, so we won't put 4. What about by the way, we are subtracting everything from A, so we don't want to see B element. So we have seen 4 is there, won't put it. What about 6? Is 6? We also won't put it because it's found in B. What about 8? 8 is not found, so we'll put just 8. So we have listed like that. Okay, so that's the thing. Okay. Okay, so that's the thing there. So what we are going to do is now, those are the elements. Okay, so for C, that was C I was solving, by the way. So make it C. This is C. Then let's this one B. Let us make this one to be B. Okay. So let's solve now B properly. So A union B. So what you do here, you list everything you list everything found in B. All right. Okay. So you list everything found in B. Okay. Okay. So you list everything found in. So when you see that, you just get everything but don't repeat. So I'll start. The lowest I can see there is 2. All right. And followed by 3, followed by 4, followed by 5, followed by 6, followed by 8, followed by 11, like that. All right. So those are the things I can see there. Okay. So that marks the what? So that is B. Then we have solved the B. We have solved this one. We have solved this one. Let's go to D. All right. So for D, we are saying that is the A complement, all right, intersection B complement. All right. So this will be with the difference from the universal. So if I list A complement, all right. So A complement, I'll list the set of A complement. So A complement with the difference with the universal, what I will do, A complement will be, all right. So A complement will be what? Those things that are not found in A. All right. So I can see. So I'll just exclude. I'll put the universal and exclude what? Exclude A members or elements. So I'll put 1 there. All right. I'll put 2 is found in that. I'll put 3, 4 is found in that. So I'll put 5, 6 is found that. Also I want to put 6. I'll put what else? 8 is subtracted, is a part of what? A, so I won't put it. Then next I'll put 7. Is 7 there? 7 should be there. All right. 8 is found in A, so I'm saying that C. I'm listing only things that are not found in A. That's the meaning of A complement. So I'll put 9 there. Alright. I'll put 10. I'll put 11. Then I'll list 12. Alright. Then I'm intersecting with the B complement again. So B complement will be things that are not found in B. We'll exclude what? 3, 4, 5, 6, 11. So I'll put what? 1 with a reference to universal. 2, 3 is found in B. 4 is found in B. 5 is found in B. 6 is found in B. 7 is not found in B. Alright. 8 is not found in B. Alright. Then 8, 9 is also not found in B. 10 is not found in B. 11 is found in B. So I want to list it. I'll put 12 like that. Alright. So what are things intersecting now? Where are they intersecting, these guys? Alright. So I can see 1 there. Alright. So 1 is there. Okay. Then what else? 3 is not there. 5 is not there. 7 is there. Alright. Is found in both. Then what else can I see? I can see 9 in both. What else? I can see 10 in both. I can see 12 in both as well. So these are the elements you are supposed to list. Alright. So that is it. So that is D. What about E? So we have solved D. So we are going into E now. Alright. So E. So we are saying for E, we are having A intersection B. So we'll bring A intersection B like that. Complement. So something that is not part of this. So we'll list A intersection B. Alright. A intersection B is having the number 4 and 6, right? So we saw here that's A intersection. So I'll put 4 and 6 like that. Alright. So now a complement of these guys. Alright. Meaning that these guys we want to list with a reference from the universal, but excluding what? Excluding 4 and 6. So when we list that, we'll have so the set will be excluding 4 and 6 from the universal. So I'll put 1 there, 2, 3, 4 no, so I'll put 5. All right, then 6 no, so I'll put 7, 8, 9, 10, 11, 12, like that. So that's the answer. Okay, so we go to EF. All right, so for F we are saying F is given as B union C. All right, subtract A, so that thing is more like subtraction A. So this is the B union C subtracting A. All right, so let's list B union A. All right, so B union C. B union C will be, you bring everything from B and C. All right, so the list I can see, the list number I can see from B or and A and C is 2. All right, so there's 2 there, 3 there in from B. Then I can see also 4, though found in both. I won't repeat it. So I'll see also 6 also is found in both. No, I'm doing something else here. All right, I'm getting from A. So the only number that can be found in A, B and C. So I'll put what from B. I'll start from 2. That's the list I can see. Then there is what 4, which is also found in C. There's 5, all right, which is found from C, in C. Then there is also what 6 from just no, I'm repeating the same thing. I'm listing A. Why? All right, so we are listing now this part here. So we are listing B union C. B union C, I can see the list number from B and C is 3 there. All right, so the next number is 4. All right, the next number is 5. Then again the next number is 6. All right, the next number again is 7. All right, again the next number is 11 from A, B. All right, so these are the thing. All right, so now we are saying we want to subtract A. All right, or remove everything found in A. Okay, remove everything found in A. Okay, so now what we are saying is so once we remove everything found in A has the elements 2, 4, 6, 8. All right, so we remove 2, 4, 6. 6 can go there, 4 can go there, so we just remain with 3, 5, all right, 7, 11, like that. Okay, so these are the elements you are supposed to write. Okay, so that's the thing there. So that now that I've run out of space, I'll delete this part. We are almost there, guys. We are almost there. We are on question 3, by the way, so I'll just cut the other part. Okay, so now we are going into that is now from solving F, so we go to G now. So G, we have A intersection C, all right, minus B, like that, or just that thing is, this thing is more like minus, please don't get confused. So I'll list A intersection C. A intersection C, I can see A in and C. I can only see 4 as the only number which is found also in C, so that is 4. all right, then minus everything found in what B. Okay, so in B, in short, once we remove in B, there is 4 as well, right? So we remove that 4. all right, so once we remove that 4, we remain with the empty set. all right, is that okay? We remain with the empty set, so don't put even a number, just write empty set like that. So that's the answer. Okay, okay, so that is it. Then for that is G, F now, no, that is GH. Okay, so H, So for H we are saying we are given to say C the same. This is minus. I've been just putting minus in case of this one. So A union B like that. Okay, so how do we do this one now? How do we do this one? We are C minus everything from A and B. So A and B have elements such as what? Elements such as what? We have elements such as, so we are listing everything from A and B. So we are getting now from B have the list I can see is 2, 3 is there, 4 is there, 5 is there from B, then 6 is in both, 8, 11 like that. Alright, so these are the things. So I'm subtracting everything found in what? In this C. C has the element 4, 5, 7 like that, right? So I'm subtracting anything that you can see. So I can see 4 there, 4 will go. I can see 5, 5 will go. Alright, 7 won't go. So I will just remain with 7. Alright, so this is the answer. Okay, so for that is the H I now. Alright, so for I it is given as B intersection C. So how do we list it? So B intersection C will put, there's only two numbers that I can see. In fact it's just 4 and 5, right? So it's just 4 and 5. So 4, 5. Alright, so these are the elements that are intersecting. We know what intersect means. So that is about I. Then what about just J? Okay, so J, let me lab here for us to do J. Okay, so we need to be fast. In terms of recording, guys, you guys were in the meeting. So this is J. In terms of you guys, I'll be recording the lesson as well while we are doing it. Yes, Jen, yeah, we'll do that. So that's what we are going to do now. We are now solving J. So J gives us what? J gives us Y, A intersection C like that. Alright, then a complement there. Okay, union B union C complement like that. Okay, so we are now getting A intersection. Alright, so we are saying now we are getting A intersection. Alright, A intersection C. So A and C, they will intersect at 4. What else? It's only at 4 there where they intersect. You can see there's only 4 there and also 4 there. There's no 5 and 6, 7 like that. So that is where they intersect. Now a complement of this guy. So union, alright, B union C, will put everything from B and C starting with a list number. So the list number we can see here is from 3B. So there's 3 there, there's what? 4 there, which is also found in everything. There's the 5 there, there's 6 there, there's 7 there, there's 11 like that. Alright, so now we are saying it's also a complement. So we want to bring everything not found in what? I mean 4, excluding 4. We'll list everything but excluding 4. So these will be from the inverse one now: 1, 2, 3, 4, no? So 5, 6, 7, 8, 9, 10. Alright, then 11, 12 like that. Okay, then union everything now. Okay, so that is the complement of this guy. So what about the complement of this? We put everything apart from these numbers. So we'll put 2. Alright, 3 no, is already there in the set. So one things that are not found in this set. So we have also 5. Alright, what else? 6 is found. So 4, 5, 6, then 7 like that. Okay, so since 7 is found also like that, then we'll put what? 7 is there, so we won't list 7. Okay, so what else? So since 7 is also found, so I'm listing things that are, even 5 is there. Alright, we don't want to see a number from here, so we are only putting 2. 3 is there, 4 is there, 5 is there, 6 there, 7, 8 now. Okay, 8, 9. all right. Then 10 is not found, 11 is there, but 12 is not found in that. So what now? We are uniting now everything we can see. So we list everything now, right? So once we add now everything, we start from the list. We put 2, 3, 4 is not found, as you can see, so I put 5, 6 there, 7, 8, 9, 10, 11, 12, like that. So they'll be following like that. All right, so that's how you list this element. All right, this question. Okay, so that is it. Let's go to K now. Okay, K is giving us what? B intersection C. Okay, union B complement. So I'll list. So for me to solve this one, I'll list first A intersection, I mean B intersection C. So B intersection C will be B intersection C. We have what? I'm sure we found it somewhere, though I've deleted. Okay, so B intersection C is now, we can see things that are found in B and C. I can only see 4 there. What else is there? 6? No. 5? No. So this is the only thing that we have there. So uniting with B complement. Now B complement is everything excluding what? B. So elements. So B has what? 3, 4, 5, 6. So in the universal, remove 3, 4, 5, 6, 11. Okay, so we are now putting 1. Okay, 2, 3 is there, 4 is there, so 5 is there, so 6 is also there, so 7, 8, 9, 10, 11 is there, so put 12 like that. All right, so uniting this, you just include now 4 at this point because you are uniting. So we'll put 1, 2, 3. No, 3 is not there, by the way. So 3 is not there. Okay, so 3, we are not putting 3, so we'll put 4 instead, which is here. Then 5 is also not there, so we'll put 7 there. 8, 9, 10, 12, like that. Okay, so that is about K. All right, so that is for K. What about just for I? Okay, so I is giving us what? I is giving us universal minus B. You remove everything from the universal, so I'll put the answer here. Remove everything from the universal, remove everything in B. All right, so I can see just remove B has the elements 3, 4, 5, 6 there. All right, so what I'm going to do is I'll remove those elements. So I'll start with 1, 2, 3 is there, I won't put. So 4, 5 is there. All right, in B 5 is there, so I won't put it. Okay, so 6 is there, so even 4 is there in B, so I won't put it. Okay, so okay, yes guys, so let's follow. Then 4 is there as well. What else? We can see what else. So 2, 3, I mean 1, 2, 3 is found in it, 4 is found in it, 5 is also found, 6 is also found in B, 7 is not found, so put 7 there. Then 8, 9, 10, 11 is found, right? So I won't put 11, instead I'll put 12. Okay, so these are the elements that you are supposed to come up with. So that's the answer. All right, so let's go to another question. We are done with everything here. So let A and B be two sets such that the number of elements in set A denoted by the number of elements is equal to 20. Number of elements is equal to number of element in A union B is equal to 34. Find A intersection B. So what you are going to do here is they are telling us to say number of element in A. Let's say these are the sets. All right, okay, so there's set A, set B there. So number of element in A is equal to 20, right? Number of element in B is equal to 26. Number of element in in A union B is equals to 34. All right, so A union B, everything is equals to 34. All right, so there's that x we don't know. Okay, so to find this one, which is found here, is the same found everything found in what, in A, because in A they are tending to say it's 20 everything, so they have x here, so I'll say here is 20 minus this x we know here, so that we know the value. Let's say x was 2, then the number of element was 20 in A, so I'll remove that 2 to get 18. So if you put 18 there, all right, if you put 18 there, meaning that will be add up 20 plus the 2 which is on the middle there, to clarify everything in A. All right, so that's what we'll do. Okay, then in B as well, we are saying we are told this 20, so we'll put the same x there, so 26 minus this x that we have put on the middle there. All right, so then everything they are saying is 34, so I'll put everything, so I'll say 20 minus x like that. Okay, plus x, okay, plus 26 minus x like that should give me 34. Okay, so now what I'll do here is 0, so I'll say 20 plus 26 minus x is equals to 34 like that. Okay, so what is this? This is 46, right? Is equals to, no, 46 minus x is equals to 34. All right, so you say negative x is equals to 34 minus 46. All right, so what is this? Negative x is equals to what? Negative x is equals to 12. All right, negative 12. So you divide throughout by negative 1 by negative to get your x. So the answer is what? Is 12 like that. So those are the number of element intersections. So on the middle there was supposed to be 12. All right, so that's the answer here. Oh, we are done, by the way. So write each of the following, write each expression as single set. Okay, so to write this one as a single set, so we'll say, okay, A intersection B, so everything now the way they are intersecting now, so we'll put as a single set. So we are saying we can only see 2 there. Okay, what else is found in both sides? I can see 11 there. There's nothing apart from this. All right, so we are done for B. Let's go for B. They are saying now A intersection B like that, we can only see that there's no number which is found in A and B. All right, so that is an empty set. All right, or you can just write like this. Okay, then for C, we are saying empty set plus everything here intersecting everything here. So this one is more like a 0 plus these, they are just these, so we concentrate on these two now. All right, so I'm saying empty set, all right, union 2 comma 4 comma 6 like that. All right, intersection 4 comma 8 comma 12 like that. Okay, so we consider this one here, uniting this everything still give us 2 comma 4 comma 6 like that. Now intersecting these two, all right, 4 comma 8 comma 12 like that. So what will be the final answer? All right, so we have 4 there, so we can intersect 4. All right, what else? There's only 4 which is found in this intersect. Okay, so we are done with that. Then we go to D. All right, so we are saying intersecting everything, then uniting with D. So let me just intersecting from this point to this point. That is for D. So intersecting those that I can see I can see 1. What else? I can see 3. What else? I can see 5. These are the one intersecting. Then unite with the 3. So I want 3 is also found in that. So I'll just get the same 3 I have. So I'll put 1, 3, 5 like that. Then I'll be done. Okay. So that is the answer that you are supposed to write there. Alright. So that is it. Let's go to the other question. Okay. So since this is question 6, somewhere around question 7 will end. All right, so for a certain university in Lusaka, for certain university in Lusaka, right, for certain university in Lusaka, okay, so first, this is a set, like, so this is how we analyze. For a certain university in Osaka, 32 female seniors were on the dean's list. All right, were on the dean's list. Then 52 women were on the dean's list who were not seniors. So these were not seniors. So 43 male seniors were on the dean's list. So 74 I mean 77 female seniors were not on the dean's list as well. So 86 male senior were not on the dean's list as well. 248 women were not senior and were not on the dean's list as well. So 66 men were on the dean's list who were not seniors. Okay, so these were not seniors. Okay, 200 men were not seniors and were not on the dean's list. So how many were seniors? Okay, so we go check on the seniors for the 50. So I'll answer A. Okay, how many were seniors in short? So 32 female seniors were on the dean's list. These were seniors. All right, so I'll put 32 there. All right, plus 52 women were on the dean's list who were not seniors, so this one disqualify. Then 43 male seniors were on the dean's list, so they were seniors, so we'll put 43 there, plus. Then 77 females were not on the dean's list, seniors, they were seniors, so we'll put 77 like that. All right, plus 86 male seniors were not on the dean's list, so these were there, so put 86. They were seniors, male seniors were not, they were just not on the dean's list, but they were seniors. 248 women were not seniors, so this one, and were, so this one, Then 66 men were on the dean's list who were not seniors, this one also no. Then 200 men were not seniors, so this, you add this, once you add this, you get what? 238, like that. Okay, that's for A. What about for B? How many were women? All right, so how many were women? All right, so here female seniors were on the dean's list, so we just want to see women. All right, how many were women's? So women were on the, so these were women, so there's women there, so there's 52 plus, is there anywhere where women is mentioned? So 2 is, again it's the women, so 248 like that. Is there anywhere we can see women? All right, so once you add these, you are getting what? You are getting 300. All right, so 300 what? Women. All right, these were senior. All right, so that's for, let's go for C. C is saying how many were on the dean's list, so we'll go on the dean's list. Females seniors were on the dean's list, so 32 is one of them, plus 52 women were on the dean's list who were, so we just want to see people who were on the dean's list, so we are on the dean's list, so we are writing also 52 plus. All right, 43 seniors were on the, they were also on the dean's list, so 43. All right, then 77 female seniors were not on the dean's list. Then 86 male seniors were not, again they were not, so 248 women were not, again 66 men were on the dean's list, so we are putting plus 66 plus. Then 200 men were not seniors and were not on the dean's list, so you add this, you get what? You get 193 if you punch, so you even write the word to say dean's list. Okay, so I want to write dean's list there. Okay, so what about for D? How many were seniors? How many were seniors on the dean's list? So we want to concentrate on the seniors, so those which were on this, so I'll go on 34 because those were the one which were on the dean's list, so 32. So they were seniors, right? So I'm consider we are solving this one. How many were seniors on the dean's list? So these ones were seniors for 32. All right, plus what about these 52 ones? Were they senior? So women were on the dean's list who were not seniors, so they were not seniors. What about these 43? 43 male seniors were on the dean's list, so we are putting now 43. Okay, then plus if at all, then let's go to this 66 we have, because those are the ones who were on the dean's list. We want to see if they were seniors. Okay, so 66 we go, men's were on the dean's list who were not so these were not seniors. Okay, so we just want to see seniors. So this, when you add, is going to give you what? Going to give you 75. Okay, so you put the word blah 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 blah, the one they want, which is were on the dean's list. Then for E, okay, so for E now we are saying, for E we are saying how many were female seniors. Okay, so seniors, so we'll start 32 female seniors were, so these were just seniors, so we write, alright, okay, plus the question is telling us to find what, how many were females. Alright, so these were women, females. 77 female were on the list, so they are just asking us how many were females. So we go where female is mentioned. The female is mentioned there, is mentioned there. Alright, where else is female mentioned? Nowhere. Okay, so we go here where it is mentioned, so that is the 77. So once you add these, they will give you what? 109. Okay, so 109. Like, you write the way that I want, blah blah blah, like that. I won't finish it, I don't have time. Then for F, alright, so for F now is going to be, so for F, so for F now is going to be so we go for how many were women on the dean, so we go where women is mentioned. Alright, so women is mentioned here, 52. Okay, so women is mentioned on the 52. Where else is women? Women is mentioned there also, that is 248, like that. Okay, so once you add those ones, they are giving you what? So no, we are putting those ones which were on the dean's list. How many women were on the dean's list? These ones were on the these ones were on the dean's list. These ones were not on the dean's list. So this one qualify. So this 244 is not there. So the only people who were on the dean's list women is 52. Alright, so that is for F. What about just for G? How many were students at the university? Okay, so what we do here is you add now. Okay, you add everyone here. Okay, we want to see everyone. Once you add this total, these ones were not seniors, but so they were just found on the university. So you add it to give you what? 8. Okay, it will give you 804, like that. So you just punch on your calculator. So let's go to the next question. Alright, so this one we'll find it, by the way, like this. So for the 1,200 first year student at the Copperbelt University in the School of Business, 250 were taking account, 200 are taking project management course, and 260 are taking both account. In short, there are two things involved there. There are two sets involved. Alright, so we'll analyze it using set property. So I'll say so let this one be universal, like that. Okay, so we are saying now 200 students, so they were total in 1,200 200 like that. First year student, the copper 250 we are taking account, all right. 250 we are taking account course, so that was just account, all right. 250. Then 200 are taking project management, and 2 course, and 260 are taking both. So those ones which are taking both is 260. We'll put 260 there, all right. So taking both project management course, how many first year students are taking account or project management course? All right. So what we do is, since we have this 260 here, we subtract to find the element which is for what, you to find the number. So we are saying 250 are taking account, so I'll put account this one. Then this one I'll say P project management. All right. So when you subtract, let me just get a calculator. Let me just get a calculator, by the way. Let me just get a calculator. So I'm saying now, what is now, since in A I just want to find in A, so they were 250. Okay, so those the ones which were taking, they were just 250 like that. All right, like that. Then those ones we are just taking account, it was 200 like that. All right. So now the question is, how many first year students are taking account or project? So you add, so you say number of account union project. All right. So this you add all of them here. All right. Okay. So once you add these guys, they will give you what? They will give you 720. All right. Like that. Okay. So taking account or project course only. All right. So we are adding now those ones that are taking those ones that we are taking these. So I would have subtracted here to get this element, but I can't do that because I'm limited. All right. So there was something here, but that's the way. Then the since you have 12,000, then when you add these and subtract, the outside part will be 490 like that, if you were to calculate like that. So that was the answer. 720 students, 710 students. All right. So if you are not clear, you inbox me. So how many subsets does the set A have? So we have set subset is equals to 2 to the power n like that. So subset is equals where n is the number of elements. So how many number of elements? 1 2 3 4. All right. So that is to the power 4. That will give us what? 16. So 16, how many subset it has? 16 subset. All right. So that is it for this one. So listing them now, listing will put, now is you start with the empty set, you list, then you put with this 0 alone. All right. Then you put again 1 alone. All right. You put 2 alone, you put 3 alone. You start now combining them now. All right. So I'll put 1 and 2. All right. Okay, so you start listing now 1 and 2. So you continue like that. So you list now 1 and 2. You go to 1 and 3. You go to 0 and 1. You go to 0 and 2. You go to 0 and 3. You go to 2 and 3. You list them, don't repeat, but just list them unique. So you put 0 and 1 and 2 like that. You put 0 2 3 like that. You put 1 2 3 like that. You list it 0 1 3 like that. and you list the last one. You put 0, 1, 2 and 3 like that. All right. Okay, so that is it. That is it for this one, guys. You have listed. That's how you list. You make sure that they are together unique. So if A is this one is equals to 14, number of B is equals to 60, and the number of C is equals to 25, find the A intersection. So there are two sets. So I'll put A and B. All right. So A and B like that. So I'll put A there, B like that. Okay. So now they are telling me to say A union B is 60, A intersection B is 20. So I'll put 20 there. All right. Okay. Okay. So now they are telling me to say find the number of A intersection B. So the way I'll approach this answer is I'll do this. I'll say, since now A union B, so the number of A minus B, which is just A intersection B complement like that, right? So those numbers should be what? Should be 14. So in short, this one you exclude when listing. You just put from in A because you don't want to be seen it in B. All right, you remove that from B. So that's what you do. Then you put 26 there. All right. So once you put 26 like that, then you say number of B now, this should be equal to, you add these ones, so that will give you what? 46 like that. Okay, you are done. So in a group of 50 people, 18 likes cold drinks and 33 likes hot drinks, and each likes at least one of the two drinks. How many like both iced tea and coffee tea? So iced tea and coffee tea is not there, right? It's not mentioned. So what I'm going to do is there were 50 people, right? Then 18 liked what? Cold drink. All right. Plus 33 liked hot drinks. All right. So now what you are going to, let's add these ones. Once we add these ones, we are going to have what? 51 like that. So once we have 51 here, these are the people who had the hot and the cold drink. All right. So they have mentioned the ice cream and coffee. So ice cream and coffee, it wasn't given the data. So what you are going to do is the difference between 50 and the 51 that we have found. All right, they were 50. So meaning that if it was to list as sets, then the inverse there 50. So meaning that they were 51, but we have found another extra. So you find the difference between these two. That will give you what? 1. So there was one extra person who was not mentioned, and they were just quiet in the universal there. So that is it. So that's one person in short. That person wasn't there. Okay. So that's number 11 now. Okay, in a certain competition, a college award medals different categories 11. All right, 11 medals in swimming, 30 medals in athletics, and 15 medals in music. If these medals went to a total of 50 participants, and only 60 participants got medals in all the 3 categories, how many received medals in exactly? All right, so what we are going to do here, okay, there's something wrong here with this question. I can see. In a certain competition, a college awarded medals in different categories: 11 medals swimming, 15 medals athletics. So I'll put like this. So swimming, then athletic like that. All right, and 15 medals music. All right, music like that. If these medals went to a total of 50, all right, they are 50, and only 6 participant got medals, all right, in all the 3 categories. So in all the 3 categories, only 3 participated, so we'll put only 6 participants got in all the, so we'll put 6 here. All right, after putting 6 in all the category like that, so what we are going to do is in all the categories, how many received medals? Exactly 2 of these categories, so we'll put those in of these. All right, so what we are going to say is a college of award medal different categories, 11 medals swimming, so 11 minus so they were supposed to be both for us to find the answer. We won't find the answer because our answer is asking in these areas. Now there is no both. What are you going to do? There's nothing. So 11 medals in swimming, so 11, so what I'll do, I'll just put 11 minus 6, that would be 5 there. Then 30 medals in athletics, so 30 plus that would be 24. Then and 15 medals in music, that would be now 9. All right, because it will add up to 15 like that. If these medals went to a total of 50 participants and only 6 participated, all the in all, how many received the medal in exactly 2 of these? So we're supposed to find answers from here. So they didn't give the data, so we can't do anything here, unless if they ask us something. So unless if we say we add this then minus the same total, they are saying 50. Maybe that will make sense, but I don't think so. So we'll say 5 plus 6 plus 9 plus 24 like that. Okay, so once we add that, all right, so that is this is 11 plus 9 plus 24 like that. So this is what, this is the 20 plus 24 like that. So that will give us what, 44 like that. So this is the answer that is showing if it was the other way around. Now that minus this one minus now 50, they are saying they are 50. So these are the guys who participated if we were to solve like this. So we are saying 50 minus that will give us 6, which is just the same people who was that they made. I don't know, they made the mistake for them to make this question. They are 65 students in production management course and 87 students in project management course. Find the number of students who are in either so this one I didn't finish, but what I'm going to do is all right, okay, this is a question. So production management course in one project management course, how when they, so we are saying they are 65 students in production management course and 87 students in project management course. Find the number of students who were in either in production management course or in project management course. All right, so when the 2 classes met at different hours and 22 students are enrolled both courses. So what we are going to do here is for A, when 2 classes met at different hours and 22 students were enrolled like that. All right, when 2 classes met at the same hour. So this has come different the way I've done it. So we'll just solve this one in the tutorial, I mean when we meet, because the way I've phrased it is not adding up. All right, when the 2 classes met at different hours and 22 students are enrolled in both. So what we are going to do is we can solve like this. Let's say we want to find when 2 students were to like that. So we are finding production management course or in project management course. So what we are going to do is we are finding the number of project management course or production management. All right, so project management course or production management or project management course, so like that. So what we are going to do is we'll add in the we'll get the number from project management course, all right, plus again the number in the project production management course, all right, then subtracting now numbers that are found in the intersect, which is the numbers that are found in project management course and intersection project in production management. All right, so like that. So once we do this, we're going to get 65 students from project management course plus 87 students from project management, that was for production 65, then minus, okay, we are finding these minus these ones were enrolled when two classes met at different hours and 22 students are enrolled in both courses, so these were in both, so that's the intersect, so I'll put 22 there. All right, so what will be this will be what, once you, it's more like 65 plus 87 like that minus 22 like that, so that will give you what, that will give you 130 student. Okay, that is it. Let's go for B. So for B now is saying, for B we are saying when two classes met at the same hour. So when it is at the same hour, what we do is we are now uniting this. So we are saying numbers of production management, all right, union, we are uniting plus the number of project management. All right, so what will be this? Okay, so in project management, production management, that was 60 what, 65. Then in project management we had the 87 students. All right, so once you add these, they'll give you 152 students. All right, so that's how you solve this one. You will do it in the next tutorial, I mean in class when we meet. So for this one we are saying, can you just do this one? So this one is saying, is negative 12, is this true or false? Is negative 12 less than or equal to 12? No, it can be, yes, it is less than, but it is not equal to. All right, it is less than, but it is not equal to. So this is the no, wait, so they are both negatives, right? So they are both negatives, so we are saying negative 12, all right, is less than or 2, like this. Are they equal to? Is it less than or equal to? All right, this is false because we can't say negative 12 is less than. Yes, is less than, but is not equal to 12, so this is false. All right, is not equal to. B, so B is saying negative 6 is greater than negative 3. Is that? No, that's false. So C is saying 4 minus, I mean, is greater than 5. Is this true? 4 is bigger, yes, yeah, but it's true, it is bigger, or it can be the same thing. Even this one should be true because 12, yes, is less, or it can be sometimes again be equal to negative, depends on the situation. So this will be, say, true. All right, this one will also be true. It can be equal at some point depending on the scenario. All right, so that is C. D, D is negative 11, is it less than 4? No, 4 is big. Let's see, 4 is big, right? This one is small, so as it approaches, because on a number line there's 0 there, right? 1 negative, like that. Let's say this is negative 4 and there's negative 7 there. Which one is big? This one is getting greater as it goes this side, so 4 is greater, so this is true. All right, so that is true. Then D, let's go to E. So is negative pi greater than or equal to positive pi? This can be true. Pi is equal to this one. Again, it can be less at some point, so it is equal. Again, it can be less at some point, so this is true. All right, so E, F. So F, negative 3 is less than or is greater than or is greater than negative 10. Is this true? Yes, I said as numbers goes to positive, let's say this is 0, then we have negative 10 there, we have negative 3. As it goes to positive side, it will be greater than. So this is true. All right. FG. So we are saying now FG 0 is less than or equal to. So 0 is greater than or equal to 0 is greater than or equal to this 12. Is this true? Yes, 0 is greater than negative 2. Again, it can be equal at some point, so it depends on the situation. So this is true. Alright, so H, we are saying now 0 is greater than negative 3. Is this true? Yes, it's true. As numbers goes to positive, negatives are less than. Those ones which are bigger are less than that one which is approaching the 0. So that is it. That's it about this one. Did I teach all the following expression without absolute error? So if I give you to say negative 2 in the absolute there, this is equal to 2. It is absolute simply means positive or minus. Alright. So if I give you, let's say, negative 2 or absolute, so this is plus or minus, open bracket, negative 2, like that. Alright. So meaning that a number will be positive. Alright. Absolute, they are there to protect number so that you can have the result of positive number. So that's what we do. So for A, we are saying you just put, so long as it's in the absolute, it should come out as positive. So here we have 1 1 15, like that. So this will still be the same 1 1 15. Alright, you have removed it, you're just removing from there. So B is saying again 1 1 15, like that. Alright, this will still give us what? The same thing again, 1 1 15. It does, there's no negative, so it won't even do anything. It will still supply the positive. So for C, we have absolute of 14 minus pi, like that. Okay, so again this will come out the way it is. So a number should be always positive, so it should be where constant, they say plus or minus a variable, right? So a variable will be there. Okay, so what we do is now you present like that. So this will be just 14 minus the same here, doesn't do anything, the absolute doesn't do anything on the negative. So the final answer is 14 minus the way it is, like that. Alright, so that is it. Then for D we have absolute of pi minus 7. So now pay attention to this one. Always a number should be in front. Alright, always a number should be what? In front. So what you do is you put this number, alright, you put this number in front there, then this one, this negative goes there. In short, what you do when you see this number is a constant one having a negative, you supply throughout a negative. So you say to make your answer, you multiply times the negative, like that, because there is negative inside of a number. So you are protecting the constant. So I'll put negative like that, minus 7, like that. So you multiply that, that would be negative pi plus 7. Alright, so now you report your answer, the constant should be in front, like that, then these variables should be like this. So this is your answer, you report your answer like this. Alright, so that's how you will do it. So for F, we're from solving what? Alright, A, B, C, D, that is D. So we go now E. A, B, C, D, E. Alright, so for E we have root of what? 2 minus 3. This is now the same case we are from doing. This one will always be there on top. So it will be you supply throughout by negative, by the way, 2 minus 3, like that. Alright, you supply throughout a negative, so that will be negative 2 then plus 3, like that. Alright, so now you report always this answer as the first. So you say 3 minus root 2, like that. So that's your answer. Okay, so for F, that is E, F now, F is given as 9 root 5 like that. So this is just okay. So what you do is, for f, what you do is you say, you just bring the way it is, and this is how you should report it. We have been reporting it in this form. All right, so there's nothing I can do with that. It's still okay. All right, let me lab this side. Okay, so for that is now f g. Okay, so there is -7 there over -7 absolute, like that, right? So what we do, absolute is always to cancel the what, then the negative inside the constant number. So here it will be now a positive, so divide by that, it should give you a negative. You are done like that. So that is g. So what about h? Okay, for h we have, so there are other absolute. All right, so for h we have, there are two absolute. Even if there are two absolute, don't get confused. So there is -5 there, another absolute, minus, okay, another absolute, then there is -11 there, then this absolute, two of them. So here we are just, they are protecting this number, so this will be 5. All right, then minus these guys. Even if there are many like this, there's absolute, they are still protecting this number, right? So that will be 11, just +11. So that will be 5 minus so there are two of them. By the way, let me just repeat it. Okay, so if I write those absolute as this one, I'll write 2 absolute, then -5 like that. All right, I write another absolute, all right, minus another absolute, all right, then -11 inside there, then another absolute, like that. Okay, so what we do is we use this absolute with these ones. So these ones will go with this one, and these ones will go with this one. So this one, I'll leave this one, so I'll put these ones that give me +5. all right, then minus these ones, they are giving me what, these two absolute, these ones, they're giving me what, +11. all right, then there's this absolute there, this one. So what I'll do is I'll say 11. What you do inside there is 5 minus 11. all right, this is absolute, so this will give you, all right, this will give you what, -6 in the absolute, which is just 6, like that. You are done. Okay, that is it about absolute. You report always your answer in that case. Okay, 15. For A, we are saying this is also absolute thing, right? So we are just there to replace now. So we are told x is 1 is 2, all right, then plus y is -3, like that. All right, there are other absolute, so we'll see. So there is that 2 minus now 3 absolute, like that. Okay, so that will be now absolute -1, like that inside, which is just giving us a positive number. So absolute, they are there to protect a number that is having a negative inside to be a positive. All right, so that for B, we are saying we know the value for x and y, so we are just subtracting. So x is what, 2 minus 3, like that, right, minus again y is what, y is -3, like that. So it will be like this, then absolute. So this will be absolute 2. Now here it will be +3, positive, like that. So this will be 5 absolute, like that. Okay, so that is it. Now absolute, you remove absolute, then you report answers like this. So you are done with that. So that is, let's go for C. So C is saying absolute of x plus absolute of y, like that. So absolute of x, you put the value of x, which is 2, plus absolute of y, you put the value of y. So I said absolute, they are there to protect the number. So this will be just 2 plus this will be now just 3 like that. So that will give me what? That will give me 5 like that. So I'm done. Okay, so that's how you can solve that one. Then D, we are from solving C. Alright, so it's still the same C and D. You just replace. So where there's X, you put 2 there, absolute minus absolute negative 3 like that. Alright, so always absolute reports the answer like that. So 2 minus absolute 3 like that. So what you do is this will also give you 2 always minus absolute of a negative inside, that should be a positive, so this will be negative 1. You are done like that. Okay, so that's about D. What about E? E is saying y over absolute of y. So y is negative 3. Absolute of y, we don't want to result into a negative again, so put negative 3 in the absolute like that. So that will be negative 3 divided by 3, which will be negative 1 like that. So that's the absolute for E. Alright, so we go for H now. So no, that is EF. We go for F. F is saying absolute of X absolute there down plus Y absolute of Y like that. So what we do is the value of X is 2 over 2 in the absolute plus negative 3 over negative 3 in the absolute. So this will be 2 into that absolute is still giving us 2 like that, then plus there's negative 3 there it will be just 3 absolute. So what we do is we look what is common. You multiply these 2, that will give you 6. 2 into that is 3 times that's 6 on top plus. Alright, by the way, that was supposed to be minus. Okay, even like this. Then 3 into that is 2. 2 times that is 2 times negative 3 like that. Okay, that will give us 6 plus 6 minus 6 like that. Right. Okay, so over 6 like that. So this will be undefined. Okay, this will be undefined. So 0 divided by 6, we can say 0, but it's undefined. Alright, it's undefined. So let's go to F, G, H. Alright, so we go to now, let me just solve H. H is giving me what? X over Y absolute like that. So what we do is we are saying that will be now X is 2, so it will be negative 2 absolute like that over Y absolute, which is negative 3 absolute like that. So this will be what? On top there it will be just 2, and down there it will be just 3, right? So this is the answer. You end there, you can divide. This already proper fraction. Okay, that is it. We are done with this page. Okay, so of the cars sold during the month of October 2023, 80 had air condition, 90 had what? Automatic transmission, 66 had power steering, 5 cars had all 3 of these extras, then 12 cars had none of these extras, 15 cars had only air conditioning, 50 cars had only automatic transmission, and 20 cars had only power steering. 10 cars had both automatic and transmission power steering. How many cars both how many cars had both power steering and air so this is a set question. So what you are going to do is let me light the universal there. All right, okay, so what I'll do is I'll write 3 sets. All right, allow me, so I'll put this one as air conditioning, then this one I'll put automatic, then this one I'll put as the power. All right, so now we are told to say 5 cars had all the 3. All right, 5 cars had all the 3, so I'll put 5 here. Okay, then this is how you start. You start on the O intersection of everything, then you come into this. That's how we fill sets. Then what I'm going to do is we are told to say 30. I saw 30 something like that. 30, where's 30? Where's 30? 30, 30, 30. All right, so so 80 cars air conditioning, 90 cars had automatic conditioning, and 65 cars power steering. 5 cars had all of these things. 12 cars had none of these. All right, so I'll put 12 which had none of these, right? 15 cars had only air conditioning. All right, so only, so air conditioning. And 50 cars had only automatic, so I'll put only. All right, and 20 cars had only power steering, so 20 as well. All right, 10 cars had both automatic and transmission, so I was saying 10 cars had both 10 cars had both automatic transmission and power, so here we are putting 10. So since 10 had both, so I'll put everything here should be 10, so here should be 5 to make 10 of both automatic and power. All right, then that is for 10 cars. All right, so what else have you remained with? What else? Okay, so we are saying 12 cars had none of these extra, 15 cars had only air conditioning, 50 cars had only automatic transmission, and 20 cars had only power 10 cars had both automatics and power engineering. All right, so since this is what we have, how many had cars both power and the steering and the air conditioning? So what you are going to do is you will add from the total, right? Then we'll see the both. Okay, so we can see here that if we add, let me get this, there's I need for the one for complement like that. All right, okay, there's something here wrong, but I'm trying to correct the error. Just wait a bit, trying to correct this error. So 20 cars at both. Okay, let's go. 80 had air conditioning, right? So 80 had air conditioning, but before I reach that, I need to know that 65 had the power steerings, 5 cars had all these, 12 cars had none of these. So what I'm going to do is, the first question is how many cars had both power and steering? All right, power and steering, air conditioning. So this is now is becoming tricky. There was supposed to be there's an error with this question. We'll just do it in class. I'm not seeing the data for this one. Alright, I'm not seeing the data. Just wait a bit. 90 had the automatic transmission. Okay, so yeah, let's do this. So for let me start with 80 had air conditioning. I'll be able to see for both. I'll start with the auto so that I collect everything. So 80 had the air conditioning, I want to do that. 90 had the automatic, so for 90 I have what, 5 plus 50 already, plus again 5. Alright, then I want to see what is here. Alright, so what I'll do is I'll say plus x should give me what, 90. So when you do that, your x will be what, when you subtract that, your x will be 30. Alright, so here it seems is 30. Okay, so that's how we do it. So I'll come now for air and power. Alright, so what I'll do is for air only, I had what, 80. So I'll put this one, 80 plus 5 plus 30, 15 plus 30 plus 5. So I need to get 80. So now I have say 15 plus 5 plus 30. Alright, so that will give me 50. Alright, so 50 minus 80, that will give me 30 here. Alright, so that is it. So now we are good. Now with this we are good. This is how we were supposed to collect. Okay, so now since we have this, so we'll start answering now. How many cars had both power pairing and air? So power and air, so we can see both, that is 35, right? You add 30 plus, so you say 30 plus 5, so those had both air and power, so that will give you 35. Alright, then B, how many cars had both automatic transmission and air conditioning? So automatic and air, so we have 30 there, we have alright, so how many cars had both automatic transmission and air conditioning? So we have automatic and air, both, those ones which had both. So we are saying it's also giving us 35. Why? Okay, it's 35. Let's say it's 35. Alright, then C, how many cars had neither power steering nor automatic steering? So we don't want power and automatic, so we'll just put 15, right? 15 plus this 12 which is outside there. Alright, so that will be what, alright, so that will be, you add 15 plus 12, so that will give you 27, like that. Okay, then D, how many cars were sold in October 2027? So when you add everything here, your answer should give you what, should give you, let me add 12. So how many cars were sold in October 2020? So you do this. The question was on the cars sold during the month of October. This one, 8 had this, everything like that. Then 12 cars had none of these extras. Alright, so how many were sold? You add everything. So you say 15 plus 30 plus 50. Alright, plus 30 again, plus 20 plus 12. So this will give you to the total of what? To the total of, if I, let me punch on my calculator. Okay, that is give me 167, like that. So for E, how many had automatic transmission or air conditioning, or you add. Alright, so what you do is you get everything from how many had automatic transmission or air conditioning, or just both, air conditioning or both. Alright, so what we do is the word or is addition. Alright, so what we are going to do is we get for automatic we have so we list the element 30 plus 50 plus 5 plus 5 plus 30 plus 20, like that. So that will give me 135, like that. So you end like that. Okay, so this marks the end of the tutorial sheet. So you can just record this tutorial, I mean get a pen, at least each of the parts you do this you write everything. Start. This is how you study, because the tutorial sheet cover all the angles on how questions can be phrased under this topic. So you are done. Once you go this tutorial sheet, then you are done with everything. Thank you very much for watching the video, and please don't forget to subscribe to our YouTube channel for more of this. There are a lot of tutorial sheets that we solved already, but your duty is just to watch this and also listen to what is inside. Take note of what is inside, you'll be led to go. Alright, so that is it. Thank you very much for watching the video, and share to others who haven't watched the video, so that their kids, they can benefit at least.